Hello, this is Mr. White, and this video is on the chain rule, part 2, combining products, quotients, and chains. Oh my. Here are the 3 exercises we're going to do in this video, and take a deep breath. This is going to be a bit intense. I wanted to see if I could get by just doing 2 of them, but I do feel like I want to do all 3 because exercises 2 and 3, although on the surface may look like they're similar, are fundamentally different. I would say that exercise 2 starts out as a quotient rule problem, and we happen to encounter the chain rule along the way. Whereas exercise 3 starts out as a chain rule problem, and we happen to encounter the quotient rule along the way, embedded inside of it. So those 2 are different enough that I want to do all 3. Let's take a deep breath and go for it. All right, on this first one, we have a bit of a choice. And there's always, I should point out that anytime I'm doing an exercise here, that there's always multiple ways of doing it, and I'm just choosing one that is of my preference, but I encourage you to explore other ways to go about it. What I'm looking at here that prompted that statement is that I could look at this as one function times another function of x, or I could look at it as a constant, 1/3, times a function of x times another function of x. I think I'm going to look at it in that sense, and you'll see the implications of that here in just a moment. But again, I invite you to consider what would happen if we had done it a different way. First thing I want to do is rewrite this as a power. So let's write this as 1/3 x to the 4th times 6x squared plus 1 to the 1/2 power. That's going to be beneficial for our deriving purposes. And we definitely see the product rule coming up here, where this might be what we think of as our f of x, whereas this would be our g of x, right? And we definitely see a chain rule embedded there. All right, so let's go to it. Let's jump into the derivative, h prime of x equals, and like I said, I'm going to treat this as just a constant hanging outside of 2 functions of x. So let's put that 1/3 out front, and then put a big old set of parentheses there, and I hope I'm leaving enough room there. Put a big set of parentheses, and this product rule is going to be applied within those parentheses. So the product rule says I'm going to take the second function times the derivative of the first, plus the first times the derivative of the second. Well, let's go ahead and write that. The second function, 6x squared plus 1 to the 1/2 power, times the derivative of the first. That would be 4x cubed, right? Plus the first function, x to the 4th, times the derivative of the second. Now I'm going to have to apply the chain rule. So watch closely. I'm going to try to do this rather efficiently, but pause, work it out if you need to on your own, see if you agree with me. I'm going to apply the chain rule on that. I'm going to bring the 1/2 in front, keep the 6x squared plus 1, just raise it to the negative 1/2 power because I need to reduce this exponent by 1, right? And then I need to multiply all that by the derivative of the inside, by the derivative of 6x squared plus 1. So that's going to be, the derivative of 6x squared plus 1 is simply going to be 12x. So again, definitely pause if you need to. Make sure you agree with that whole first line. At this point, the calculus is pretty much done, and we've just got some nasty algebra ahead of us. Okay, so let's take a look at what we got here. Let's start cleaning up a little bit. I, of course, have the benefit of experience, so I'm going to do a couple things because I know what's coming up. That's something that you don't have yet, but you will be gaining, and I invite you, again, to always think ahead. Think a step ahead as to what you can do to make your next step easier. What I'm going to do is I'm going to not do too much with that first expression. I'm going to just write this as is, but I'm going to leave a little space because, again, my experience tells me that I'm going to have something coming up where I'm going to need a little space. Oops, that's to the 3rd power. And then 6x squared plus 1 to the 1/2 power. I'm going to leave a little bit of space afterwards, and then put plus, and now I'm going to address this mess here. Let's see what we got there. We've got 12x times a 1/2. That's going to give me 6x, right? And then 6x times x to the 4th will give me 6x to the 5th. 6x to the 5th. And that's all over 6x squared plus 1 to the 1/2 power. Again, take that negative exponent and move it down below as 6x squared plus 1 to the 1/2 power. Okay, again, pause, make sure you agree with all of that before proceeding. But now, do you see why I left that space there in the preceding term? It's because I want to have a common denominator. I saw this fraction here coming up, and I knew that I was going to need a common denominator. Again, as a new student, you're not going to see that right away, but with experience, you can start to have those insights. So here's how I do the common denominator. I'm going to do 6x squared plus 1 to the 1/2, because that's my denominator over here, and I need that common denominator. And since I have that in the denominator there, I have no choice but to put it up here in the numerator as well. And I say I have no choice as if that's a burden, but actually it turns out to be a big favor to us here. Let's look at what happens next. Again, this is just some nasty algebraic cleanup here. Here's why that was actually a nice benefit for that first term. Again, we have our common denominator. Let me go ahead and write that denominator there, 6x squared plus 1 to the 1/2 power. But you see the benefit up here? Look at what happens when I multiply those two. I get up here 4x cubed, and then when I multiply these two, the exponent basically goes away, or at least it becomes a 1. So I'll just get 6x squared plus 1 to the 1 power. So I'm not even going to bother writing it. Plus 6x to the 5th. That's what I got from over here, right? So the clouds are starting to part. Let's proceed. Let's continue cleaning this up algebraically. All right, all the actions taking place up there in the numerator. Let's proceed here. Up here in the numerator, let's distribute and combine like terms. So 4x cubed times 6x squared will give me 24x to the 5th. Distributing that 4x cubed to the 1 will give me plus 4x cubed plus 6x to the 5th. That's all over 6x squared plus 1 to the 1/2 power. Close parentheses. I'm going to try to squeeze another one on this line here. So let's combine the like terms. We've got that and that. That's going to give me 30 x to the 5th plus 4x cubed. And don't worry, we're nearing completion. There's just one or two more things I want to do. As long as I've got a factor out front, I might as well try to factor out any greatest common factor I can from here. And again, when we start applying derivatives, we're going to find that often it's nice to have our derivative in factored form, and for reasons that I'll get into at another time. But let's go ahead and completely factor this. It's already partially factored with this. Let's completely factor it and take out, let's see what the greatest common factor is here. It looks like a 2x to the 3rd power can be taken out of that numerator, right? So let's go ahead and write that as a 2x to the 3rd power. And what would be inside those parentheses? Well, we'd have a 15x squared plus just a 2, right? Again, the idea is that if you distribute 2x to the 3rd times 15x squared, you would get this. Whereas if you distribute the 2x to the 3rd times the 2, you would get this, 4x cubed. So I've just done some factoring there. And that is all over. I'm going to go ahead and let that 2x cubed take the place of this 1 here. I'll have the 3 on the bottom still. And then 6x squared plus 1 to the 1/2 power. And that was our derivative. I can't even remember what letter we started with. I want to say h of x. Yes, this was h prime of x. So let's call that h prime of x and put a box around it. There are some ways that I might go about checking this answer, but just for time's sake for this video, I'm going to go ahead and go on to the second exercise. So now we're trying to find the derivative of this function, and this is the one that I'd characterize as outwardly a quotient rule problem, but embedded inside of it is a chain rule problem. So let's dig in. And what I mean by that is that the quotient rule is the first thing that I'm going to tackle. I look at that first and foremost as a quotient, and I'd say that z prime of x equals, and let's go ahead and apply our quotient rule. And also, let me do what I did in the last video. Let's rewrite that as a power first. Now, when you get experience with this, you could probably just think of that as a power in your head, but for the sake of this video, while you're new to this, I'd like to actually have it there visible on the screen. So, okay, let's look at that. And again, we'll consider this you might think of as your f function, whereas this you might think of as your g function, if you're used to thinking of the quotient rule in terms of f over g. So if we speak in those terms, the quotient rule says to take g times f prime of x, the bottom times the derivative of the top. Let's go ahead and do that. So 1 plus 3x squared to the 1/3 power times the derivative of the top. That's going to be just 2, right? Minus the top times the derivative of the bottom. So the top will be the 2x plus 5. And the derivative of the bottom, again, I'm going to need to apply my chain rule. Hopefully we're comfortable with that. So taking the derivative of the bottom will give me 1/3 times 1 plus 3x squared. And again, I've reduced this exponent by 1, so 1/3 minus 1 is negative 2/3. And then all of that is times the derivative of that inner function. 6x in this case. Okay, and all of that is over the denominator squared, the g function squared. So let's write that as 1 plus 3x squared. And it's to the 1/3 power, but since I'm squaring it, let's go ahead and call that to the 2/3 power. Again, I could have written that as a 1/3 and then a parentheses and then a 2 on the outside, but I'll just prefer to do it that way. All right, the calculus is over. Let the algebra begin. Okay, so once again, I'm going to take advantage of my experience, which I hope you'll be trying to get a sense of how I'm predicting these things. What I'm predicting is that once again, I'm going to leave myself a little space. I'm going to largely leave that alone, but leave some space. Let's call that 2 times 1 plus 3x squared to the 1/3 power, and leave a little space there, minus, and then let's tackle this mess here. We do have a little bit of good fortune here in that the 6x kind of cancels out that fraction. So 6x times 1/3 will give me 2x times 2x plus 5. However, we still do have a fraction going on here, right? Because we've got a negative exponent for this expression. So let's put that in the denominator as 1 plus 3x squared quantity raised to the positive 2/3 power, all over that denominator. And we see that my prediction, again, involves a common denominator situation. So let's move that up and think of what is it I need to put here to make a common denominator. Well, it's going to be 1 plus 3x squared to the 2/3, and then same thing on top, 1 plus 3x squared to the 2/3 power. All right, we do have a bit of good fortune. That's always a good feeling in these messy processes where things just seem to, where you do get little rays of sunshine here. And what I'm referring to is, look at what happens here to this numerator. something similar happened in the last exercise. That does clean up rather nicely. We have our denominator, so let me start with the denominator. This is the denominator I'm referring to. Let's start with that. 1 plus 3x squared to the 2/3 power. And up top here, this cleans up nicely to just 2 times 1 plus 3x squared quantity. So 2 times 1 plus 3x squared, close parentheses, minus this numerator. So I'll go ahead and just keep it factored for this step, and in the next step we'll FOIL that out and combine like terms and all that. Now, I could write that all over this denominator right here, right? At the risk of losing you, I want to go ahead and do something that I encourage you to warm up to. I could write this all over a big fraction bar, but I'd still have the fraction within a fraction. So what I'm going to do is I'm going to go ahead and address that. I'm going to say instead of dividing by this, I'm going to multiply by its reciprocal. That's how we handle fractions within fractions, right? So instead of doing a big fraction bar and writing this underneath, instead let's multiply by its reciprocal. 1 over 1 plus 3x squared to the 2/3. And that'll set me up nicely in the next step, and I won't have that fraction within a fraction situation anymore. All right. You are loving algebra right about now, I am predicting. So let's see what we have here. Let's go ahead and distribute that, and be careful, make sure you distribute the negative, of course. 2 plus 6x squared minus 4x squared minus 10x. All over this times this. We simply add the exponents, right? When we're multiplying those expressions, we add the exponents. And we are almost done, ladies and gentlemen. This wonderful journey is almost over. Let's just simplify the top. 6x squared minus 4x squared will give us 2x squared. Let's write this quadratic in standard form. So the quadratic term first, followed by the linear, followed by the constant. All over that denominator. 1 plus 3x squared to the 4/3 power quantity. And finally, our final answer. Let's factor out the 2 up top. Again, like I said, we will often find that having our derivatives in factored form is beneficial. If I were able to factor this quadratic cleanly, factor it across integers, I would do so, but I can't. This cannot be factored across integers, so I'll just leave it. I'll just be satisfied with taking out that greatest common factor of 2. And that is our z prime of x. Put a box around it again. In class, we'll go over how might one go about checking something like this, but we're going to call this one done for now. All right, on to the final exercise. Find the derivative of this function, big B of t. And again, this is going to involve both quotient and chain rule, just like the last one, but notice that it's really a quotient rule inside of a chain rule. If I do my familiar kind of f of g setup, and I'm even going to try to use the same color coding I've used before, I think of the outer function, our f of x, as being blank to the 5th power, and the inner function is going to be the t cubed minus 1 over 4 plus t squared. Again, I haven't done any calculus yet. That's just rewriting and color coding the original function. So let's move that over here. All right, so let's start with our derivative. Let's start b prime of t. And again, rather than start looking at it as a chain rule problem, we're starting by, as a quotient rule problem, we're starting by looking at it as a chain rule problem. Take this off to the side and say, I'm going to derive that green function right there. I'm going to derive that and get 5 blank to the 4th power, right? Now that I've got the distraction out of the way, let me bring it back and put it back in here. T cubed minus 1 over 4 plus t squared. I don't derive it here, but I derive it afterwards. I put the derivative here. So let's go ahead and launch on into the quotient rule here. So taking the derivative of this, we're going to do the bottom, the denominator, times the derivative of the top. So bottom times derivative of top, derivative of that t cubed minus 1, minus top times derivative of bottom, which is going to be 2t. And that's all over bottom squared. 4 plus t squared quantity squared. All right, calculus is over, and algebra remains. Let's turn our attention to this mess over here. And actually, let's go ahead and just write the beginning part. We're not going to try to do anything with this first expression here. Just write it down. And let's turn our attention to that messy numerator over here. All right, so let's distribute everything. 3t squared times this is going to give us 12t squared plus 3t to the 4th. And then minus, taking care to distribute the negative, of course, minus 2t to the 4th plus 2t, all over 4 plus t squared squared. Let's clean up a little further. And I'm anticipating something up ahead. I'm noticing that this denominator here is the same as this here. So I'm going to separate what's going on here. Watch how I do this. Rather than try to explain it, let me just show you. I'm going to separate that into t cubed minus 1 to the 4th power over 4 plus t squared. Again, I'm looking ahead, 4 plus t squared to the 4th power. So rather than have this entire quantity raised to the 4th power, what's separating it up into one quantity to the 4th power over the other to the 4th power, what that's going to do for me is it's going to allow me to combine with this, as you'll see here in a moment. So that's going to allow me to combine with this 4 plus t squared squared in the very next step. Let's go ahead and complete this messy numerator here. Let's combine our like terms. 12t, let's do the t to the 4th terms first. 3t to the 4th minus 2t to the 4th gives me just 1t to the 4th, plus 12t squared plus 2t. All right? Let's do a couple things here and then call it a day. Let's look at this quadratic here and see if we can factor anything out. Looks like our greatest common factor is simply going to be just a t, right? So let's factor out the t and combine it with this 5 here. So let's put 5t. I'll go ahead and address this quadratic here. So having factored out the t, and I keep calling it, did I just call that quadratic? That's not really a quadratic, is it? I apologize for that. This expression here, this 4th degree polynomial, just became 3rd degree because I factored out the t. And I'm looking at that and I'm going, okay, I don't think I can factor that any further, so I'm just going to leave it be. Let's go ahead and put this up there. T cubed minus 1 to the 4th power. And it's all over this. Let's combine those two to give 4 plus t squared to the 6th power. And I think we're using big B, right? So let's call that big B prime of t equals this. And one last time, we'll discuss checking techniques in class, but we'll call it done for now.